My name is Mike Maines. I'm with the Modal Shop, and today I'd like to talk to you a little bit about Python and the Digiducer and a simple script that we can write to take 2 seconds worth of data. It's not a perfect app, but it's simple and it will get you started and get you familiar with the Digiducer and how to talk to it via Python. We have just 19 lines of code here. The first 3 lines are 2 comments and a blank space. After that, we talk to the libraries that we need to import in order to make our script work. The first one is the most important one for talking with a Digiducer, and that's the sound device library. We import that, the MATLAB plot lib, so we can plot our 2 seconds worth of data, and then the NumPy so that we can put our data in arrays and be able to plot it. So those are kind of the 3 primary things that are needed. If you haven't installed those, you'll need to pip install those libraries so that you can import them. The first thing we're going to do is set up the sampling rate, and we're going to sample at the Digiducer's maximum sample rate of 48 kilohertz. We're going to take 2 seconds worth of data, and then we're going to build a buffer or calculate the buffer size so that we can tell the sound recorder how long to take the data. Line 11 here is where we actually call the sound device record function. We pass it the buffer size, the sample rate, and tell the sound recorder that we're taking 2 channels worth of data. That's important that you take 2 channels of data when you're using a Digiducer or a DigiDAC. We're then going to use the SD wait command to wait until the recording is finished, and after that we're just going to build a time axis for our data to plot it, and then plot the data and set up the X limits and the title and a couple of labels. And you'll notice that I've put the data as unscaled amplitude. It comes back to us without any engineering units applied. We'll talk about how to do that in a subsequent video. So let me start the application. I'm going to hit the run button here to run the Python file, and then I'm just going to pick up the transducer. I'm not going to tap it on the table. I don't recommend you do that, but I'm just going to shake it up and down, and you can see here that we have 2 seconds worth of data. And that's a moderate oscillation that I can do by hand. I'm going to go ahead and close down this figure window, and the next thing we're going to do is actually turn on a hairdryer, or if you can find a device in your home, that a fan or something that makes noise, vibration, you can attach that. But what I'm going to do is turn on the hairdryer, start our Python script, and then place the Digiducer on top of the hairdryer so that we can see the vibration measurements. So turn on the hairdryer, turn it on high, run the Python script, and then attach the Digiducer to the signal. And you can see there, I timed it about right, about halfway through starting the script. I applied the Digiducer to the hairdryer, and you can see the vibration signal quite clearly there versus no vibration on the signal. So again, a very simple app in the Digiducer, and again, you can get unscaled data. The danger with this script is it will work with the Digiducer disconnected. So I'm going to unplug my Digiducer from the computer. I'm going to run the script, and now what I'm doing is I'm just recording sound with the default microphone on my computer, and you can see that that occurred. So that's the downside of that. And then we're going to cover in the next video how to scale our data and to make sure that we're talking directly with our Digiducer or our DigiDAC. Thank you for your time.